So easy start where we make statistics simple and easy. So in this case, we are going to advance our knowledge on repeated measures. This is now a two-way where we have two factors. And in terms of factors, we mean treatment. We have one treatment here or one factor which has A, B, C, D. These are just dummies. A, B, C, D variable, A, B, C, D levels. So which are four levels. And then the other factor, of course, is about time, because we can say that it is repeated measures that as we had explained. Repeated measures is just an advance of a paired t-test, whereby we have similar subjects being measured more than twice. So this is the first measurement, that is growth at 7, growth at 14, and growth at 21. So we want to see, and also these are treatment that were applied. Do we have a significant difference for the growth of these? Let's say it's the pad for the growth at 7, 14, and 21. And do the treatment differ, or do the treatment have an impact on this growth at all these levels? So you go to analyze, general linear model, repeated measures, and then of course the factor within subject. This is about the time, of which in our case here it is growth. And then they were measured 3 times. The number of level was measured 3 times. Then you click and then you define. So in this case, you move the dependent variables, which is the growth at 7, 14, and 21. And then of course, between the subject factors is the treatment. So you move it here. Then you come to options, whereby we can decide now to display the means, and also we can compare the means. In this case, I'm not interested with this. I just want to see for the growth and the other one. Then click continue. Another important thing is the plot. The plot really gives us some. So you can plot at the horizontal axis, we have the treatments, that is ABC, and then the growth we can have at separate lines. And then now we click continue and just click OK. So here we have our results. Remember, the most important table is this is the first most important tables. The sphericity. Remember, sphericity is the substitute of homogeneity in the other ANOVA test that we usually do. That is one of the assumptions, whereby we expect that the variance be across this group at time 1, at growth 7, growth 14, and growth 21. That is the first time the data was collected among the subject, the second time and third time, the variance is okay. So, and in this case, you can see that it is significant. So we reject our null hypothesis and say that the variance is the variance is not equal across the three measurements. So we use a corrected epsilon, which is measured using the greenhouse gases, whereby once you measure, you get it. So you can see here it is 0.668, which is higher than 0.05. So whenever we'll be interpreting our results, we shall only use the greenhouse gases. There are other methods, but we recommend using the greenhouse gases method in interpreting the repeated measures. So when we come here, sorry, when you come here, the growth, you can see that. So we are not going to use the sphericity assumed, because we've already seen that it has violated that assumption. So we are going to use the greenhouse gases. And when you use the greenhouse gases, you can see this is the main thing that we are interested in. That is the p-value. And you can see it is less than 0.05. So we can say there is a significant difference across the time measurements, whereby you can say at growth 7, at growth 14, and growth 21, there is a significant difference across them. And then we can try to see what about between treatment and the growth and treatment. So we can see that there was no significant difference. So despite any time of when the growth was being done, or despite at growth 7 and you apply different treatments, there was no significant difference. So let's go to the other thing here that is very important. Is so here it's about the growth, and then now I'm interested with this plot. So when you see about this plot, you can see that growth at 1, 2, 3. So at 1 was that was at 7, at at 7. This is at 7, at 14, and at 21. So see, at 7, this was the mean. At 14, this is the mean. So you can see that there was a significant difference across the times. As times go by, there was an increase. But if you go in terms of the treatment, at 7, you can see it is almost equal. At 14, you can see A is a little bit higher compared to the rest, but there was no significant difference. Similar to this. So that is how you can perform a two-way repeated measures in SPSS. Thank you, and remember to subscribe.